Hey everyone, this is Cookie Code. So now I am outside for once at least, and I saw this big pumpkin. And I was thinking, this is how big my YouTube channel will be in the future. So make sure to subscribe. Hey everyone, this is now James from home, and today we'll be looking at scikit-learn, and we'll be looking at how we can evaluate a model's performance, how we can create models in scikit-learn such as linear regression, logistic regression, random forest, and all of that, as well as many other things. To install it, we just need to run conda install scikit-learn or pip install scikit-learn. I'm actually now into something that's called Jupyter Lab, and this is just going to allow me to explain scikit-learn really easily and with a lot of visual interaction. So it's going to be great for all of you guys. First things first, let's re-verify that we have scikit-learn installed, and we can do this by just doing import scikit-learn.version. And if you run this by using shift enter, it will just show this, and it will just show the last value you are putting. So let's start by loading the dataset, and the dataset we'll be using in this video for now is going to be the iris dataset. And if you look at the description from scikit-learn, it's a dataset that consists of 3 different types of irises, so setosa, versicolor, and virginica, and contains 4 features, so they are stored in a 150 by 4 NumPy array. As you can see, I have written the lines we need to load the dataset, and basically we just need to run from scikit-learn.dataset import load iris, and then you can just run load iris, and we get a dictionary such that it has data as a key, and this is like the data, so 4 features and 150 datasets, and we have our target, which is the label of it. So let's just use this, and we can ignore all of this since we don't really need to use this all. So what we can do is just say iris dataset is equal to this, x is equal to iris dataset data, and y is equal to iris dataset target. Let's run this, and we don't get anything else, and we can just run x.shape, and it's 150 by 4, and you can do y.shape, and we get 150. So this is what we want. Now the next step is splitting our data set into a training set and a test set. And what this is going to do is that our model will only look at the training set to learn everything he needs to know, and then he will only be evaluated on the testing set. That way we're sure that the model is not doing any kind of memorization, and that he's truly learning the patterns behind the dataset. To do this in scikit-learn, we need to use a method that's called from sklearn.model_selection import train test split. So you pass in x and y, and it's going to split x into x-train, x-test, and it's going to split y into y-train and y-test. And here this parameter test size equals 0.2 is just going to say that I want my test size to be 20% of the whole data set, and random state equal 42 is just something I put to make sure that our split stays consistent, so the split won't change and will always be the same, just so that we can reproduce the experiment. Now if you run this, you'll see that it's working, and you can just directly say, hey, what's xtrain.shape, and then it will tell you, and you can also do what is xtest.shape. So it's 30, so as you can see 30 is 20% of 150, and you can also do what's ytrain.shape, and finally you can also take a look at the shape of ytest. So everything makes sense. Now the next step is pre-processing, and what this means is that we have to make sure that the data we'll be feeding to our model is in a format that our model will appreciate. And for most of the machine learning models, they all like to have each of the feature having a mean of 0 and having a standard deviation of 1. And we can do this in scikit-learn by using a class called standard scaler. And the way you do this is just by running this code. So ss is equal to standard scaler, so ss for standard scaler, and you can fit this, so ss.fit xtrain, and it's going to learn the means and standard deviations in the training dataset, And you can apply this to xtrain and to xtest later by doing standard xtrain is equal to ss.transform xtrain and ss xtest is equal to ss.transform xtest. We can verify our model had an effect by looking at ss xtrain dot mean axis equal to 0 and ss xtrain dot standard deviation axis is equal to 0. As you can see, the standard deviation is 1 and the mean is a really small number close to 0. So these are negative exponents and they're like 0.0000000000000 whatever. So that's good enough for us, and let's just keep that as the mean. Now it's time to do some modeling, and what we're going to be doing is that we're going to test different models. And it's okay if you don't understand what the names mean. I will be making videos on each of the models and how they work, but for now it should be enough to just know that they're just different ways of having a model classify something. So for example, random forest classifier, linear discriminant analysis, decision tree classifier, logistic regression, and k-neighbors classifier are all different ways, different algorithms and different models that will all perform classification. Most of the time, if you're just doing machine learning, like applied machine learning, you don't even really need to know what they do, and you just select the model with the highest accuracy. For now, you don't need to know what all of these names mean, but it is going to be useful later on. So for example, if you're trying to find out why this model isn't performing so well on this dataset, if you know how it works, you can then find and see, oh, it's because my dataset was not correctly formatted for this kind of model. So for example, linear discriminant analysis expects your data to be in the shape of a bell curve, so with a mean of 0 and a standard deviation of 1. And if you don't provide data that is standardized, that's the name for it, then it's for sure not going to perform well. In scikit-learn, it's so easy to use these models. You just need to do model is equal to random forest classifier, put some parentheses, and here you can modify how you want your model to behave. So there are some parameters you can read up on it, such as max estimators, max depth, all of that. And you really don't need to memorize them by heart. You just need to know that they exist, and you can always search them up on scikit-learn documentation. So for example, I can do shift tab and they also show me what is inside. So for example, n estimators, that's what I was talking about, max depth, and all of these are things you can change. And if you continue, all you see is you just run model.fit, you pass in the training dataset, the training labels, and then after that you just do ypred is equal to model.predict testing dataset. And you don't put the labels here, you just put this like that, and this is going to work. So for example, let's see, I run this, and you can see there are no errors, and you can evaluate the accuracy score thanks to scikit-learn.metrics. I can just run, for example, accuracy score, ypreds, and ytest. Actually, it's going to be ytest first and then ypreds. And if you run this, you see I get an accuracy of 100%. So let's take a look at it again. You can do a classification report like this, ytest and ypreds. And as you can see, it's not formatted correctly, so make sure to print it to make sure that it is formatted correctly, and you get this beautiful table. So basically there were 10 features here in the 0 class, 9 features in the 1 class, 11 features in the 2 class, and they were predicted with 100% accuracy. And by the way, this will never happen in real life. In real life, if you ever see a 100% accuracy, you're most probably doing something wrong. But this is a really easy data set, so it's normal why you get such a great accuracy. So if you look at this, it is pretty easy. You just create your model, fit it, predict it, check the accuracy score, print the classification report, and that's literally it. So we can make that into a function and just test how our other models are going to perform. So what we can do is say define evaluate model, and this is going to be model right here, and the only line we need to remove is this line here. We tab and we can do this. So we can do let's just only print the classification report, since I think that's the thing that's the most useful. Print it, and that's it. And finally, what we can do is just make sure that you can pass a title. So title, and it will print classification report for title, and that's it. So now let's evaluate all our models. So evaluate model. So let's just say models is equal to this. So all models is this. Now you can just use a for loop and do for model, title in all models, evaluate model, model, title. And this is it. So now you see, we have spot tested every single model, and every single model has an accuracy of 100%. So this is really boring, but you know what? This is how it is in life, and simply because it's really an easy data set. But most of the time, you won't see such perfect numbers like 100% accuracy, and you'll have to select which model is the best just by looking at these metrics. Of course, there's a different way of measuring the accuracy of a model, such as cross-validation, but we'll do that in another video. And that's all about scikit-learn. I hope you enjoyed this video.